All of you, can you see the problem? All of
Yes,
you,
sir.
can you see this problem? See, today we are going to perform the practical, and the name of the practical is structural analysis. Okay, and in structural analysis, we are going to see the bar under torsional load. Okay, so see, previous we have taken the structural analysis for the bar with axial load. After that, we have taken the structural analysis for bar under axial load with thermal effect. Right now, we are going to see the structural analysis for bar under torsional load. Okay, so you might have seen that this problem we already solved in a lecture. Right, this problem we already solved in a lecture. Right, so we are interested here to compare the solution. Okay, what you're getting the results by analytical method, those same results we need to compare by the what you can say software. Right, so see what we have this stepped bar. Right, so this stepped bar, so for each bar you have different diameter. For first one it is 100 mm, for second one it is 80 mm, for third one it is 50 mm. Right, at the same time you have different length of the bar. For first bar it is 450, for second bar it is 400, and for third bar it is 500. Right, in addition to that they have applied the torque, okay, 3 kilonewton meter in, let's say, anti-clockwise direction and 2 kilonewton meter in clockwise direction. Okay, this bar, it is made up of a material with value of G as 100 gigapascal, with value of G as 100 gigapascal. Now all of you, as you can see in the problem, so very basic step in FEA is the discretization. Okay, so meaning of discretization is to divide. Okay, what is the meaning of discretization? Is to divide. Okay, so basically you need to divide this entire domain into number of subdomains. Right, so what we are going to do here is, okay, as see, you have three different diameter. That means what, you'll get three different cross sections. So based on this criteria, we have divided this entire domain into three elements. Okay, as you can see, this is element number one. Okay, this is for this bar, then this is element number two, this is for this bar, and this is element number three, and this is for this bar. Right, so as you can see, you'll get three elements. So as there are three elements, you'll get four nodes. Okay, so this is node number one, this is node number two, node number three, and node number four. See, node number one will connect an element one to this fixed support. Right, element number two will node number two will connect element one and element two. Then node number three will connect element number two and element number three, and node four will connect element number three to the fixed support. Okay, is it okay with this one?
Yes, sir.
Okay, so this what we have done, we have just formed the elements and we have numbered the node. Okay, now as you know that for creating the nodes, you need to have the coordinates of every node. Right, for creating the nodes you should have the coordinates of every node. Okay, so for locating the coordinates to every node, okay, we need to measure the location of every node with respect to some other node. Right, we need to measure the location of every node with respect to some other node. So obviously one of the node we need to take it as a reference node. So what we'll do, we'll assume the node one as a reference, so its coordinate becomes 0 and 0. So we'll measure the location of rest of the node, that is node number 2, node number 3, and node number 4 with respect to node number 1. Okay, so as you can see in the problem, what is the location of node 2 with respect to node 1? See, what is this length? This length, it's 450 mm. Okay, so this becomes 0.450 meter. Okay, so that is the location of node 2 with respect to node 1. That is 0.45. Right, next, what is the location of node 3 with respect to node 1? This is the length, or this is the distance between node 1 and node 3. That is this 450 plus 400, that is 850. That is 0.850 mm. Okay, meter, 0.850 meter. Next, what is the location of node 4 with respect to node 1? This is the total distance. That is 450 plus 400 plus 500 mm. So this becomes 1350 mm. That is 1.350 meter. Okay. So is it been clear with this one?
Yes, sir.
Is it been clear with this one? Okay. Are you able to understand how I assigned the numbers to the nodes, or rather coordinates to the nodes? Is it
Yes, sir.
okay?
Yes, sir.
Okay. So now see, when you form the elements, when you number the nodes, right? Then assign the coordinates to every node. Then this is enough to solve the problem by using ANSYS, right? So this much only is required. Okay, what is required? Right? See, you just form the elements, number the nodes, and give the coordinates to every node. Okay, so this is enough to solve the problem by using ANSYS, right? So now we'll start with the ANSYS. Okay, so we'll start with this mechanical APDL product launcher 16.2, right? So as you can see this window. You can see, all of you can see this window. Is it okay? Can you see this window, all of you?
Yes, sir.
Yes, sir.
Okay. So see, this is the stimulation environment. As I told you, this is always ANSYS, right? This is always ANSYS. The license which we have, it is again same, academic teaching advanced, right? See this working directory. So here I will browse the folder where I want that work to be saved. Okay, so I will save it here. Okay, I'll just save here in FEA, this folder, FEA practical TEME1. Okay, here only I will save this. Okay. Here I will save our work. Okay, see here, if the folder in which you want to save the work, if it is not giving the option to add the new folder, you need to go back. Okay, and then you create the folder and you save your work in that particular folder. Is it okay? Is it okay or not? Okay, now see, this is experiment number 4. Okay, so I need to go back. Okay, I will just go to this computer. I'll go to desktop. I'll just open this folder TME1. I will create here new folder. That is experiment number 4, right? Now what I will do is, here I will browse that. Okay, I'll just browse that. Okay, I browse that folder. Okay, I just browse that folder. So whatever the thing that I'll do, it will be saved in that particular folder only, right? Now see, we need to change the job name, right? What is your job name? It is structural analysis bar under axial load with thermal effect with torsional load. Bar under torsional load, not axial load, bar under torsional load. Okay, structural analysis bar under torsional load. Understood? Structural analysis bar under torsional load. Okay, so if you just bring this window vertically up, okay, so here there you can click the option of run. Okay, you can see the option of run. Okay, okay, just click here, just click the option of run, right? Just click it on run. Okay, so all of you can see this window. You just maximize that window, right? Can you see this one? Can you see this window, all of you?
Yes, sir.
Can you see this window? Okay. Now we need to start with the problem, right? Now
Change the color.
tell me all of you how to start it.
First of all, change the color of background, sir.
I'll do that. Plot control, go to plot control, and we need to go to style, right? We'll just change the color, then color, and this reverse video, right? Style, see, go to plot control, style, color, and reverse video. Okay, so you can change the color of the background, right? Now see, in between, you just keep on clicking this save db. Okay, just keep on clicking the save db option, right? Now tell me how to start.
Preprocessor.
See, before going to preprocessor, you just go to preferences, right? Because we need to select the field in which we are going to solve that problem. Okay, so see, the elements in that particular field will be available only and only when you select that field. Okay, so if you see select the structural field, then only the elements of the structural field will be available, right? Okay, so just say okay. Clear? Right? Now what is the next step? We need to go for preprocessor, right? Is it okay? Now we'll go to element type. We'll go to element type because we need to define the elements, right? So I'll go to add, edit, delete, right? Add, edit, delete. Then I will just click on add. Okay. Now see here, I will select this beam element, right? Beam 2 node 188. This element I will select, right? Beam 2 node 188. This element will be, I'll select, right? Beam 2 node 188. So I'll just say okay, right? I'll just close this window, right? So this element beam I have selected,
link
right?
select क्यों नहीं है? Last time जैसा.
See, when see, it is not a problem. We can go by using link also. Okay, we can go by link also, but in the link we will never get the option, okay, to enter this diameter, right? Is it okay or not? See, I'm selecting the beam, so we can enter the value of a cross section. Okay, for beam we can enter the section, and in section I will select the circular cross section with this as a, okay, with this as a diameter. Is it okay? Now see, the properties which are available for the link, or rather the properties which are available for the beam are not available for the link. Okay, because here we are interested to apply the torque, okay, which you will never get it in a link. Is it okay? Understood?
Yes, sir.
Okay, because we are interested here to apply the torque, okay, which will not be able to apply in a link, right? So that's why I'm selecting this as a beam element. Is it okay?
Yes, sir. Got it.
Okay. Now see this one. So now see, when you select the element as a beam, there is no need to go for real constant. If you want, just go there. Okay. You'll get a message, right? This beam does not require real constant, right? Is it okay? Because if you try to put the value of real constant, it will not allow. Okay. Next step will be go to material properties. Next step will be to go for material properties, right? So in material properties, we need to go to material models, okay, because we need to add the properties of the material like modulus of elasticity, right? Modulus of rigidity. This we are supposed to add. So see, as you can see in the problem, okay, let me see the problem. Okay, see this entire structure, it is made up of a single material with value of G as 100 gigapascal. Okay, and now whatever the previous problem we have solved, we are not able to enter the value of G. Okay, rather we need to put the value of E. Okay, getting or not? Okay, yes or no? Whatever the previous problem we have solved, in that we have entered the value of E. Okay, but in the problem they have given the value of G, so it is necessary to calculate the value of E from the given value of G. Okay, so there is a relationship between E and G, and that relation is given by E is equal to twice of G into 1 plus mu. Okay, twice of G into 1 plus mu. Okay, so you put this value twice into G is 100 gigapascal into 1 plus This is Poisson ratio. It is always 0.3, and this is coming to be 260. Okay, so if G is 100, what value of E you are getting? It's a 260. You're getting its value as 260. Okay, now just come back to problem. Okay, we'll go to material model. Okay, so we have a single material, that is material number 1. We'll go to structural, right? Then we'll go to linear, we'll go to elastic, then we'll go to isotropic, right? Yes or no? So see, it is asking to enter the value of E, that is 260 gigapascal, that is 260 E9. Is it okay? Is it okay or not? Let me know.
Okay, sir.
See, in the problem, value of G was given, G, that is 100 gigapascal. So from G, we are supposed to calculate the value of E, that is E is given by twice of G, 1 plus mu. Okay, so that E was coming to be 260 and Poisson ratio was 0.3. Okay, so I'll just say okay. Okay, so there is no need to create more materials because you have a single material there. Okay, so I'll just close this window. Okay, then I'll minimize this. Now see, when you doesn't enter real constant, obviously you need to go for a section. Okay, so for section, just come back to the diagram. Okay, for first one it is 100 mm diameter. For second one it is 80 mm, and for third one it is 50 mm. Is it okay? 180 and 50. 180 and 50. Okay, now just come back to this. We'll go to section. Okay, we have a beam. Okay, right? Because we have selected that as a beam. Okay, now we'll go to common sections. Okay, now when you go to common sections, can you see this window? All of you, can you see this window?
Yes, sir.
Okay, so see, ID is 1. ID is 1. Okay, so I will enter here section 1. I will enter here section 1. Okay, now it is, see, this is what in my ID, it's just like a set. Okay, so we need to create 3 sets: set number 1, set number 2, set number 3, and you just give the name as per your convenience. I'm calling this as a section 1. Okay, now I'll go to subtype. Then see, this rigid circular section I need to select. Okay, you have this rigid circular. Okay, and what is the radius? See, the diameter was 100 mm, right? Okay, so that means 100 mm means what? It is 0.1 meter, 0.1 meter, right? Yes or no?
0.5.
Okay, it is not 5, it is 0.05, na? Yes or no? This is 50 mm, na? 50 mm. Is it okay or not? Let me know.
Yes, sir.
Yes, sir.
See, diameter was 100 mm. Okay, so obviously radius will be 50 mm. Okay, and in meter it is 0.050. Is it okay? Right? Is it okay with this one? See, we need to create 2 more sets. So I will click on apply. I will click on apply. Right? Now I will enter ID as 2. Right? Then I will enter section. I will enter the section 2. Okay. Then I will enter the subtype. Okay. This is a circular. Okay. Rigid circular. Then for second one, diameter was 80 mm. So radius will be 40 mm. So 0.040. Is it okay? Is it okay or not? Let me know. Is it okay with this one?
Yes, sir.
Let me know. Okay, so again I will click on apply because I need to create one more set. So I'll just say apply. Okay, now I will enter the ID as 3. Okay, that is section 3. Okay, again I will select this as a circular. See, this is circular, right? This is circular, right? Then radius is, the diameter was 50 radius is 25, that is 0.025. Is it okay? Now I will say okay. I'll just say okay, right? So I'll minimize this section beams. I will minimize this section. Okay. Is it okay with this one? Is it okay with this one or not?
Yes, sir.
Okay. Now see here, all of you. Now here we need to see once we are done with this section, we need to go for modeling, right? So in modeling, we need to first create the nodes. Okay. So I'll go to create nodes. Okay. So for creating the nodes, I should know the coordinates of node. Okay. I should know the coordinates of the nodes. Right? Is it okay? So for C, just see here, for node number 1, it is 0, 0, right? For node number 1, it is 0, 0, right? For node number 2, it is 0.45. Okay. For node number 3, okay, see here. For node number 1, it is 0, 0. Okay. So I will go node by node. Okay. I will go to node in active CS. For node number 1, it is 0, 0, right? I supposed to click on apply, but I will click on OK. Okay, so I'll go to OK. Node number 1 is created. Then I will go to node number 2. It is 0.450. Okay. Node number 2. It is 0.450. Right? Yes or no? I will click on apply. Otherwise, see why I'm not clicking on apply. See, if I will click on apply here, and if I go here to see the image, then it may happen that it may hang, right? So that's why I'm clicking on OK. I'm clicking on OK. So this is node 2. Now for node number 3, it is 0.85. Right? So again, I will go to inactive CS, node number 3, and this is 0.85. 0.85, right? So I'll say OK. I'll go to again node number 4. This is 1.350, right? 1.350. So this node number 4, it is 1.350. Okay. Yes or no? Is it okay with this one?
Yes, sir.
Now see, all of you see here. See, this your form it as a nodes. Now let's say if you form one of the node, okay, wrongly you form one of the node. Okay, so see all of you. In a modeling as like a create, you will also get the option to delete it, right? So you can see the option to delete. Okay, so what do you want to delete? I just want to delete a node. You just click on that node which you want to delete and define elements which you have yet not defined. Okay, so it will not allow me to delete the elements because till now I have not formed the elements. Okay, so now let's go to create. Now we need to create what? Elements, right? Elements. Okay, so before creating the elements, we need to set their attributes. Okay, so see here, all of you. This element number 1, for element number 1, see what is changing for every element. Let me, what is changing for every element? It is its section, right? What is changing? Its diameter is changing, right? And diameter we have taken into account in terms of section, right? Getting or not? Let me know.
Yes, sir.
See, for every element, value of G is same. That means material property is same, right? For every element, that is element number 1, 2, and 3, element type is same. That is 2 node, beam 2 node 188, right? So what is changing for every element? It is its section. Only section is changing because in section you entered the value of diameter, okay, which is different for different element, right? So I'll go to elements, element attributes. Now see, as I told you, element type, it is same for everyone. So this will remain only as beam 188, right? Then material number, it is same again for every element. So it is to be remain same only. Okay, now see here, all of you. See, real constant, we are not defined because it's a beam element. Okay, now we will go to section for element number 1. Obviously, section is 1 only. Element number 1, section is 1 only. So there is no need to change anything. So I'll just click on cancel. Okay, because by default, okay, he is going to assume, or rather ANSYS is going to assume the properties of first element only. Okay, by default. So I'll just go to auto numbered, right? I'll go to through nodes because I need to connect element number 1. I need to connect element number 1. Okay, so what I will do here, see this window will come, right? So this window is going to basically ask to pick the two nodes. Okay, to pick the two nodes in between which I want that element to be connected. So see, I want element number 1 between 1 and 2. Okay, I want the element number 1 between 1 and 2. So this is node number 1. Okay, see, you can see here. Once I click here, you can see here node number 1. Okay, when I click here, you can see the node number 2. Okay, and how many total nodes are selected? Their count is 2. So node number 1 and node number 2 are selected, their count is 2. Okay, so I will say okay. I'll just say okay. So this element is connected. Is it okay with this one? Right? Now see, we will go to again create elements. Again, we need to change because see, now we need to create element number 2. So before creating the element number 2, we should set their properties, right? How will do that? Just go to element attributes, right? Everything is same, only the section is going to change. That is section 2. Section 2 we need to take. So I'll just say okay. Okay, now when I go here, that is auto number through node. Okay, now again I need to pick the 2 points, 2 nodes rather. So I'll select node 2, I'll select node 3. Okay, and I'll say okay. So these 2 nodes have been connected with the element number 2. Now again I need to create element number 3. Okay, so I should set their properties. So I'll go to element attributes. Its section number is 3. I will say okay, right? Now I'll go to through nodes. I'll select node 3, I'll select node 4, and I'll just say okay, right? So this is how the elements are connected. Is it okay? Is it okay? Is it okay to everyone?
Yes,
Yes,
sir.
sir.
Okay, now see all of you. If you want to see whether you correctly form the nodes and elements or not, you need to go to list, right? Just go to nodes. Okay, we just going to see first nodes have been correctly formed or not. So we are going to list and nodes. I'll just say okay. So see, these are the coordinates of node 1, node 2, node 3, and node 4. Okay, so 0, 0, 0 0.45, 0 0.85, and 1.35, right? So it is okay. We'll go to list. Now I want to see the elements. So I'll go to list, elements, then nodes plus attributes plus real constant. Okay, so I'll go here. Can you see this one? Element number 1, element number 2, element number 3. Material is same for every element. That is 1, 1, 1, right? Type is again same. That is beam 188. That is same. Real constant, there is no real constant, right? And section is 1, 2, and 3. Section. Okay, this is section number 1. That is of 100 mm diameter. Section number 2, it is of 80 mm diameter. And section number 3, that is of 50 mm diameter, right? Now see, element number 1, it is between 1, 2. Element number 2, it is between 2, 3. 2, 3. And element number 3, it is between 3 and 4. Is it okay? Can you see this one? Can you see this one? So I'll just click on closed, right? Now that means we have correctly formed the nodes and elements, right? So there is nothing in the create now. So we'll just close it, right? We'll just minimize the modeling, right? Now the next step, tell me what will be the next step to us? Okay, that what we should do next. Let me know. Tell me what we should do next.
Load.
Right, we should go for loads, right? We should go for loads. Okay, now tell me how we should apply the load. How we should apply the loads. Right, so we need to go to loads, right? Then we need to go to define the loads, right? We need to apply it, right? We'll go for apply, then we will go for structural, right? Now see, before applying the loads, okay, before applying the loads, we need to make it fixed, right? We are supposed to make it fixed, right? That means we need to apply the boundary condition. So if you can see at node 1 and at node 4, structure is fixed. That means those nodes cannot move. Okay, that means displacement at node 1 and at node 4 is 0, right? Displacement at node 1 and node 4 is 0. Okay, that we are supposed to apply. So we'll go to displacement, right? On nodes. So I will select this node. I will select node number 1. Then I will select node number 4. Okay, so 2 nodes I have selected. I will say okay. Okay, and I will constrain those nodes in all directions because they are fixed. To what value I am constraining them? To 0. See here, value of displacement. I am putting that value as a 0. Okay, now I will say okay. So these 2 nodes are constrained in all directions. That is node number 1 and node number 4, right? So see, once you make it fixed, after that you need to apply the force or moment, right? So you can see the problem. All of you just see the problem. See, at node number 2, how much torque you applied? It is in kilonewton meter. Okay, we want that to be Newton meter. So it is 3000. This is 3000 and this is 2000. 3000 and 2000 Newton meter. 3000 and 2000 Newton meter, right? Okay, so now see, at node 2 it is 3000, it is in anti-clockwise direction, and at node 3 it is 2000 but it is in clockwise direction, right? Okay, at node 2 it is 3000, that is anti-clockwise, and at node 3 it is 2000, that is clockwise, right? So I'll go to force or moment on nodes. Okay, now see, now I will select this node number 2. Okay, because I need to apply the force or moment at node number 2. I'll just say okay. Okay, now see here, you can see the option here. Okay, we have movement and we have the movement about which axis? About which axis? About x-axis. See, you have the rotation about x-axis. You can see in the problem, you have rotation about x-axis. So at node number 2, what movement you have? You have 3000. Okay, I'm taking it as a plus because it's a positive value, right? Because it is in anti-clockwise direction. It is in anti-clockwise direction. That's why it is positive. That is 3000, right? Is it okay? Is it okay or not? Is it okay? Let me know. Is it okay or not?
Yes, sir.
Okay, now I need to apply one more movement. So I will click on apply. I will just click on apply. Now I will select node 3. Right, I will select node 3. See, I have selected the node 3. Then I will say okay. Right. So I need to apply one more movement, that is at node 3 with value as minus 2000. Okay, because it is going in clockwise direction. See, 2 kilonewton meter. What is 2 kilonewton meter? It is 2000 Newton meter, right? It is 2000 Newton meter. Okay, and that 2000 Newton meter, it is in clockwise. So that's why I taken it as a minus value, right? So this is minus. So I'll just say okay. Okay, so is it okay with this one? Is it okay with this one? See, if you want, you can see the diagram. See, you have the movement about which axis? You have the movement about x-axis. See here, this is x-axis. Okay, this is x-axis. Is it okay? This horizontal line, it's a x-axis. Okay, horizontal line is a x-axis. So this bar is going to rotate, or you're going to apply the movement about the x-axis. You're going to apply the movement about the x-axis. Is it okay? Is it okay with this one? See, this is x-axis. So this rotation, it is about which axis? About x-axis. Is it okay with this one? Let me know. Is it okay with this one? Is it okay? Is it okay to each and everyone?
Yes, sir.
Okay. So I will just minimize this one, apply, I'll minimize, define the loads and minimize the loads, right? Now just come back to the problem and just see anything is missing that we have yet not entered. Just check it. Is anything is missing that we have entered, yet not entered? That we have yet not entered? Is there anything that we have yet not entered? See, everything we have entered now, right? See, this diameter we have entered in section. Just now we applied this moment, torque. Okay, this 450, 400, 500, we have taken into account when we have formed the nodes, right? This value of G, we have entered in terms of E in material properties, everything we have entered, right? Now we should solve it, right? So we need to go to solution, just go to solve and say current LS. Okay, solution, solve, current LS. So you can see the message. Solution is done. Okay. Can you see this one? All of you, can you see this one?
Yes, sir.
So I'll just close it. I'll just close it. Now our problem is solved. Now we need to just fetch the answers, right? So from where we are going to do that, we need to go to general post prop, right? We need to go to general post prop, right? So initially we are going to see the diagrams, and then we are going to see the answers in terms of numerical values. Okay, so for seeing the visualization, we need to go to plot the results, right? Then we need to go to deform shape, right? See, this is the practice which we usually used to do for every problem, right? We'll go to deform shape. Then see, here you can have options. Okay, whichever you want, you can select. I'll be selecting this deform plus underage. So I'll just say okay. See, this you will get as only a 1D diagram. Okay, so from that you might not be able to understand very much, right? Is it okay? So what we'll do here is we'll just make that. Okay, we just plot that 3D diagram. We'll go to plot control, style. We'll go to this size and shape. Okay, plot control, style, size and shape. I'll just stick it so it becomes on, right? So, and I will just click on OK. Okay, so this diagram you can see, right? Can you see this diagram? Right? Can you see this diagram? All
Yes,
of you?
sir.
Okay, this is the diagram when you're going to apply the torque. Okay, at node 2 and node 3. Okay, but this diagram you're getting only for a deformed shape. Deformed shape you're getting this diagram. Okay, this you're getting for the deformed shape, right? Is it okay with this one? You see, if you want to save this image, just go to plot control and just capture the image, right? Plot control and capture the image, right? and wherever you want to save that, just save that file and save as, right? So wherever you want, you save that file, right? Clear? Now, now I'll just say the displacement. I need to see the displacement, right? See, if you can see, you just able to see only the diagram or how it is going to get deformed. You'll be able to see that, okay? But you are not getting those answers for the displacement, okay, with the diagram, okay? So for that, we need to go to counter plot. We need to go to nodal solution, okay? Then see displacement, it is nothing but degree of freedom, and see in degree of freedom, let me know which option I should select. In degree of freedom, which option I should select. Let me know which option I should select. Tell me, any one of you, just tell me which option I should select in DUF solution. See, let me know immediately. Almost 31 students are there. Okay, so let me know which option I should select. Huh? See, whether you have displacement in X direction, let me know whether you have displacement in X direction,
No,
linear
sir.
displacement in X
Rotation
direction.
around x-axis.
Right, you should have this X component of rotation. You have the rotation about X axis. X component of rotation, that is rotation about X axis. This you should select. Okay, so I'll say okay. So can you see this diagram, all of you?
Yes, sir.
Okay, now see, you can see here the point where you have, okay, this blue region. See, you can see here blue region, and you can see the red region. Okay, so you see the value of displacement, it is increasing from blue to green to yellow and finally to red. Okay, so likewise it is increasing, right? Is it okay with this one? Okay, similarly, if you want to capture the image, go to plot control, capture the image, right? See, this will give you the value, that is not a problem. Okay, but you won't get the value at the nodes, okay, from this one, right? Because you're not listed it as per the nodes, right? So I'll just see the front view. I'm going to see this front view, right? So I will just minimize it in counter plot. I'll just minimize plot results. Now I'm going to see the numerical values. Okay, I will go to list result. I will go and I will go to nodal solution. Okay, because I need the values of displacement at the nodes. Okay, then I will go to DOP solution. Again, I should get the X component of rotation. Okay, see, this is the angular rotation, right? Angular displacement, and angular displacement, it is called as rotation, rather, right? So I'll select X component of rotation. I will say okay. So you can see this value. Displacement at node 1 is 0 and displacement at node 4 is 0. These are the boundary condition which we applied. Okay, and what is see, this 2 means what? This is theta 2. This 3, it is means what? Theta 3. Okay, so these values we have got, right? These values we have got, right? This is, see, this is theta 2 and this is theta 3, and this value, it is in radian. Because we are measuring the angular displacement, that is rotation. So angular displacement or rotation, it will be measured in terms of radian. Okay, so both of this value, I will rate this value. It is 0.5325. See here, this value 0.53256 into 10 raised to power minus 3. This is into 10 raised to power minus 2. See, this is how you're going to read the value, right? So this is your displacement. Angular displacement, and that is rotation, right? Similarly, we should know the reaction, because at node number 1 and node number 4, see, at node number 1 and node number 4, structure is fixed. So the point where structure is fixed, at that point you will get the reaction. So you will get the reaction at node 1 and node 4. Okay, so let's see here. So for that we need to go to reaction solution. Okay, now see, you have applied the torque. You applied the torque about x-axis, right? You applied the torque about x-axis. So obviously you will get a movement about x-axis only. Yes or no? You will get a movement about x-axis. So I will select this structural movement mx. I will select this structural movement mx. See, because you have applied the movement about x-axis, so obviously you will get a reaction about x-axis. That is mx. I will click on OK. So these are the values you will get. Now see, all of you. See here, it is very interesting. Okay, you can see this one. Okay, I'll just write down here. Okay, now see here, all of you. See, what is the displacement at node 1 that you got? What is the displacement at node 1? For node 1, what is the displacement? Or rather, for node 1, what is the reaction? It is minus 11.59, minus 1159, minus 1159.5, right? Right? Now for node 2, see here, for node 2, what force you applied? You applied at node 2. How much you applied? You applied 3000. You applied 3000. At node 3, how much you applied? How much you applied? You have applied minus 2000. See here, how much you applied? You applied minus 2000, right? And at node 4, how much you are getting? How much reaction you are getting? It is 159.46. See here, all of you. See this value, right? So if you take their summations, okay, if you take their summation, okay, what value of summation you are getting here? What value of summation you are getting here? It's a 0 value. Understood or not? Let me know.
Yes, sir.
Here, see this value, and this value. See this value. Can you see this value? Similarly, this value, you got it. Okay, as an answer or as a result, these two values, you got it as an answer or result, right? Now these two values you have entered, right? These two values, node 2, right? Node 3, node 2 and node 3 you entered. See, the node 2, that is 3000, and node 3, that is minus 2000, that we have entered. Okay, and this node 1 and node 4, we have calculated this value. So if you take summation, it is coming 0. Getting or not? Let me know, getting or not? Is it okay or not? See, if you are unable to get it, just here. What is here? It is 3000, and what is this? It is minus 2000. 3000 and minus 2000. What is that? It is 1000. Is it okay? See, 3000 and minus 2000. That is 1000. So in order to balance this 1000, some reaction should be produced at node 1 and some reaction is to be produced at node 4. Right? Some reaction has to be produced at node 1. Some reaction has to be produced at node 4. Okay. So as you can see, see, this is what is the reaction produced at node 1? It is this minus 1159.5. What is the reaction produced at node 4? It is 159.46. So if you take the addition of these two, it is coming 1000. Yes or no? So in order to balance that minus 1000, this 1000 is produced. Okay, out of 1000, minus 1159.5 is produced at node 1 and 159.46 it is produced at node 4. Is it okay?
Yes,
Is it
sir.
okay or not? Is it okay with this one?
Yes, sir.
Okay. So now what we'll do is, So this is our reactions, right? Now what we'll do is we will just see the animation. We'll just see the animation, right? So now we need to see the animation of this one, right? So we'll go to plot control, animate, and we'll see the deform results, right? So which deform results we need to see? We need to see the rotation about x-axis, right? We need to select the rotation about x-axis, right? So I'll just say okay. So you can see this diagram, or rather you can see the animation. Can you see this one? All of you, can you see?
Yes, sir.
Okay, can you see this one?
Yes.
Okay, so this is how we have performed. This is how we have performed this. Okay, this is how we have performed this practical. Is it okay? Is it okay? Is it
Yes,
understood
sir.
to everyone?
Yes.
Is it been understood to everyone?
Yes, sir.
Yes, sir.
Okay.